Hi, welcome to Allen High School's discussion of models of atomic theory at the pre-AP chemistry level. Now we're going to begin our discussion in something of a unique manner, maybe unexpected for those of you who are just getting into chemistry. And that's with the discussion of light and the properties of light. Now there's a very good reason why we do this, and that's because the models of our electron are actually based upon our understanding of light. There's the mathematics. Whoa, sorry about that. The mathematics involved in this is very similar to the mathematics of light. Not only that, it is thought that light, electromagnetic radiation, also has particle-like behavior. So we call this kind of the dual nature, something of a split personality, but it's not like sometimes light behaves as a particle and sometimes it behaves as a wave. It's really that the mathematics of these do an adequate job or a good job of explaining what we understand about light. So we call that particle a packet of light, and it's called a photon. We'll see this in more detail in just a minute. So let's first talk about light as a wave, and in order to do this we have to talk about the speed of light, and we do that in a vacuum. And we use the symbol C for that. And there's two values, one of which you will be given, one which you should really learn. It's 3 times 10 to the 8th. That's rounded. It's like 2.998 or something like that. Meters per second. Now, wavelength of light, the length of the wave, is often given in nanometers. So it's helpful to learn this one as well. So you'll want to memorize that because it will help you with your calculations. You won't have to do so many conversions and dimensional analysis because yes, indeed, you are going to have to do dimensional analysis with this. So let's review those parts of a light again. The wavelength is given the Greek letter lambda in chemistry. Okay, so it's like you draw an upside down V and then give it a leading edge there. And any unit of length is appropriate, but mostly you're going to be seeing meters, centimeters, and nanometers. All right? Now, frequency. If I have this wavelength of light, and if I put a detector, I'm just going to put my eyeball there as if I could count. And if I counted at this point how many waves went by in a particular time, like if you stood on a corner of a street and you counted the number of cars that went by, that's the frequencies of cars going by that. Now, for chemistry, we use the Greek letter nu. It's sort of like a cursive V. Now, in physics, they'll use F, which seems a little bit more logical, but that's just the way it is. I guess we want to distinguish ourselves. And the most common units are 1/seconds or seconds to the -1, or also named after a dead guy named Hertz. All right. The electromagnetic spectrum, what you need to know, definitely this. You don't have to, memorize every detail of every wavelength, but you have to get the big picture in your mind. And so we're going to look at this. You have to memorize that visible light goes from 700 to 400 nanometers. And you need to know the order. Roy G. Biv is a common phrase for doing that. Red, which starts at the 700 end, orange, yellow, green, blue, indigo, violet, violets at the 400 end. Okay. Now, what about the rest of the light that isn't visible? What is that order? And there's a good acronym that we have for that as well. So let's take a look at that picture. And I've just given you kind of a schematic for us to fill in. So let's take a look at that. If I can get my inking pen onto the document. Sorry about that. Let's get down there again. Here we go. All right. So as we look at this, we want to label this. This is 700 nanometers. This is 400 nanometers built in for you. So this must mean that this is long wavelength. Okay. And this end is short We use long and short for wavelength, all right? Now, we'll see that frequency is the opposite. So this is low frequency, and this is high frequency. And this is low energy, and this is high energy. All right. Now, as we look at this, this would be your radio, and this is going to be your microwave. You know the symbol micro. This is the microwave. That's what we cook with, right? This is your infrared. Notice that it's just below red, infrared. This is, of course, your visible range. This is your ultraviolet. Ultra is above the violet end. And then we have X-rays and gamma rays. And you need to know that order because we want to get this picture in your mind, not just on a piece of paper. And a way to do this is red, Martians invade, Roy G. Biv, that's the visible, using X-ray gizmos. So radio, microwave, IR, visible, UV, X-ray, gamma rays. Okay, so that would be our overall spectrum that you have to, those are the details of the spectrum that you need to know. Okay, so that's going to be it for this video. We will be moving on into doing some more calculations of this. Until then, this is signing off.